Hello everyone. In today's topic, we are going to talk about direct variation. And under this lesson, we are going to have the warm up first, the lesson presentation, and you will gonna do your worksheet 4. For the warm up, here are the questions. Regina walked 9 miles in 3 hours. How many miles did she walk per hour? Correct. It is 3 miles per hour. Second, to make 3 bowls of trail mix, Sandra needs 15 ounces of nuts. How many ounces of nuts does she need for 1 bowl of trail mix? Correct, it is 5 ounces. In this topic, you are going to learn to identify, write, and graph an equation of direct variation. So these are the vocabulary words that you need to know. Direct variation, constant of variation. So most of the time, we are going to talk about direct variation and constant of variation. What is direct variation? Direct variation is a linear relationship between two variables that can be written in the form of y equals kx or k equals y over x, when we are going to divide both sides by x to solve for k, where k is not equal to 0. The fixed number k in a direct variation equation is the constant of variation. So k is the constant of variation. We can read direct variation as y varies directly as x, or y is directly proportional to x, or y varies with x. So let us identify whether an equation is a direct variation or not. So supposing we have y plus 8 equals x. In here, we first interchange it. So we have y plus 8 equals x. And then we are going to subtract 8 from both sides of the equation. So subtracting it, so we will be getting y equals x minus 8. And from here, we can see that the equation is not in the form y equals kx. So y plus 8 equals x is not a direct variation. Now let us have another one. 3y equals 2x. In here, the first thing we need to do is to solve for y. So we are going to divide both sides by 3. In doing this, so we are going to have y equals 2 over 3 x, or 2/3 x. And from here, we can see that the equation is in the form y equals kx. So the original equation, 3y equals 2x, is a direct variation. So let us have another one. Y plus 3 equals 3x. So in here, we are going to subtract 3 from both sides of the equation. In doing this, so we will be getting y equals 3x minus 3. So as you can see, the equation is not in the form y equals kx. So y plus 3 equals 3x is not a direct variation. Now let us have another one. 4y equals 3x. So in here, we are going to divide both sides by 4. So we will be getting y equals 3/4 x. So as you can see, the original equation is in the form y equals kx. So the original equation for y equals 3x is a direct variation. Now let us identify a direct variation from a table. So we are going to tell whether each set of data represents a direct variation. If so, identify the constant of variation, the k, and then write the direct variation equation. So we are going to identify k as well as the equation. So suppose we have this example. We are going to find y over x for each ordered pair. Why? Because we need to find k. So we have 2 over 69 and then 3 over 99, which is equal to 1 over 33. And then we have 4 over 129. So k is not the same for each ordered pair. So we can conclude that the data does not represent a direct variation. So if we can get different constant of variation or k, then this data is not a direct variation. So this is a helpful hint. In a direct variation where k is positive, when x increases, y also increases. When x decreases, y also decreases. Now let us have another one. So let us tell whether each set of data represents a direct variation. The first thing we need to do is to identify our k, or constant of variation. So in here, we have to divide y over x. So the first one is 2.54, the second one is 2.54, and the third one is 2.54. So what can we deduce from here? We can say that k, the constant of variation, equals 2.54 for each ordered pair. So therefore, the data represent a direct variation where k equals 2.54, and the equation is y equals 2.54, which is the k times x. Now let us have another one. So we have the price and the weight. So let us see if this data represents a direct variation. So the first thing we need to do here is to find k. So as you can see, we have 2 over 5, and then 3 over 10, and 4 over 15. So what can you conclude from this? So k is not the same for each ordered pair. So therefore, the data does not represent a direct variation. Now let us have another one. So let us find the constant of variation k first. So as you can see here, we have 3, 3, 3 all along. So therefore, k is equal to 3 for each ordered pair. And therefore, the data represent a direct variation where k equals 3 and the equation is y equals 3x. Now let us identify if a graph is a direct variation or not. So if so, we are going to identify k as well as the equation. So looking at this graph, we can say that the graph is a line through 0, 0. This is a direct variation. Why? Because the slope of the line is 1/2. And since the line is sloping down to the right, your k is equal to negative. Because as you can remember in your grade 9 math, when the line is sloping down to the right, we have a negative slope. So in here, we have a negative k, okay? So the equation is y equals negative 1/2 x. So here's a helpful hint. In a direct variation, the slope k represents a constant rate of change. So if the line is sloping down to the right, the k is negative. If the line is sloping up to the right, it is positive. So let us tell whether this graph represents a direct variation. So in here, as you can see from the graph, the line does not pass through 0, 0. So therefore, it is not a direct variation. So let us have some application for direct variation. A truck travels at a speed of 55 miles per hour. Write a direct variation equation for the distance y the truck travels in x hours. So the first thing we need to do here is to recall our formula for the distance. So distance equals the speed times the time. So distance equals 55 miles per hour times number of hours. So from here, using the formula y equals kx, y equals 55, and the number of hours is unknown, so we represent it as x. So we will be getting y equals 55x. So the next step that we are going to do here is to make a table. And then since time cannot be negative, we are going to use a non-negative or the positive number for your x. So if x is equal to 0, y equals 0. So we have the coordinates 0, 0. If x equals 1, then y equals 55. So we have the coordinates 1, 55. And if x equals 2, y equals 110. So we have the coordinates 2, 110. Now we are going to graph. So in graphing those coordinates, so we will be getting this graph. Then connect the coordinates or points. So we have this line. And to check, so y equals 55x is in slope form with m equals 55 and b equals 0. If you can remember your slope-intercept form, y equals mx plus b, where m equals the slope and b equals the y-intercept. So whatever the number beside your x, it is your m. So the graph shows a slope of 55 and a y-intercept of 0. So let us answer the question, how long does it take the truck to travel 660 miles? So from here, we are going to find the value of x when y equals 660. In doing this, so we are going to use the equation y equals 55x. And then we are going to substitute y equals 660. And then we are going to divide both sides of the equation by 55. And then x will be equal to 12 because 660 divided by 55 is equal to 12. So it will take the truck 12 hours to travel 660 miles. Using the direct variation equation while y equals 55x. Now let us have another one. A bicycle travels at a speed of 12 miles per hour. So we are going to write a direct variation equation for the distance y the bike travels in x hours. The first thing we are going to do here is to have distance equals 12 miles per hour times number of hours. So using the formula y equals kx, we are going to have our direct variation equation, which is equal to y equals 12x. Since the number of hours is unknown, so we are going to represent it as x. So the next step that we are going to do here is to make the table of values. So from our previous example, since time cannot be negative, so we are going to use the positive numbers for x. So if x is equal to 0, y equals 0. So we have the coordinates at 0, 0. And then if x equals 1, y equals 12. So we have the coordinates 1, 12. If x equals 2, y equals 24. So we have the coordinates 2, 12. So using those ordered pairs or coordinates, we are going to plot the points. And then we are going to connect the points. So we will be getting a straight line. So y equals 12x. So from here, from the slope-intercept form, y equals mx plus b, where m is the slope. So slope equals 12. And b equals y-intercept, which is equal to 0. So let us answer the question, how long does it take the bicycle to travel 96 miles? So we are going to find the value of x when y equals 96. So first, we are going to write the equation for the direct variation. Y equals 12x. Then we are going to substitute 96 for x. Then we are going to divide both sides by 12. 96 divided by 12 equals 8. So therefore, it will take the bicycle 8 hours to travel 96 miles. So that's it for now. Thank you for watching. See you again next time. Bye.